Guys, thanks for clicking on question 3. So here is question 3. It reads as follows: a circle with radius 6 centimeter is drawn. A second circle smaller is drawn through the center of the first circle. Okay, so it means the first circle, when it's drawn, the radius of the first circle, it means it's the bigger one, this one. Okay, because they are saying the second one is smaller, so it means the first one is this one, the second one is this one, the third one will therefore be this one. Okay, so they are saying a circle is drawn with a radius of 6, so it means from here to there it's 6 centimeters, so therefore this is the radius. Okay, and then through the center of the first circle and also touches the first circle internally. Okay, there you go, as shown in the diagram. A third circle is drawn through the center of the second one, so a third one is this one, through the center of the third one and touches the center and touches the second circle internally. The process of drawing circles continues and forms a geometric pattern. Okay, because guys, immediately when they say geometric pattern, you must know that you will be using Tn, it's equals to Arn minus 1, and then also you'll be using Sn, it's equal to Arn minus 1 close bracket all over R minus 1. These are some of the things, and then you would have to determine the ratio, which is given by T3 over T2, which must be equal to T2 all over T1. Okay, great stuff. So therefore, let's go 3.1. I hope we understood the question, guys. I hope we're together here. 3.1 said write down the radius of the third circle. Okay, so now if the first one is 6 centimeters, the question says it's drawn and then touches internally. So it means the radius of this one, of the second circle, is just half of this one, so it's just going to be half of this one, which is 6 divided by 2 is 3. And then you have this one here, which is going to be half of this one. Okay, so the radius will be somewhere there, which is going to be half of 3 divided by 2 is going to give us 3 over 2. Okay, makes sense, guys? Makes sense. All right, so now they said we need to determine the radius of the third circle, so it's just going to be 3 over 2. Okay, all right. 3.2 says calculate the sum of the areas of the first 10 circles. Okay, so basically this means that our n needs to be 10. And then what are they saying? They are saying the sum, so it means we need to find Sn. Okay, so but now what happens here when you are looking for these circles? Okay, so if we have a look at this one, let's see what happens. So they are saying the sum of the area, sum of areas. So sum of areas, what is the area here? The area of a circle is what? Is pi r squared. Okay, let's say this is for circle number 1 plus that of pi r squared, circle number 2 plus that of pi r squared, circle number 3, and they're on up until pi r squared, circle number 10. Okay, so now if you have a look at here, guys, we have got a common factor here, which is pi. So what we can do here, we can take out a common factor of pi from this pattern or sequence. You see now it has formed a pattern, guys. Like they said, it's a geometric pattern. 1 squared plus these are You can't take them out, guys, because they are not the same. Remember, r changes every time. Okay, so there we go. We take out this common factor. We take out the common factor of pi. So this is what we're gonna be left with, r squared 10. There you go. So now if you see there, what are we left? We're left with that. So it means basically what we are left with, if we can substitute r, let's come here and see the type of a pattern that is formed. Okay, now we're focusing on the type of pattern because we have taken out that. The type of pattern that is formed here is formed by r1, okay, squared r2 squared r3 squared. Okay, so now let's substitute r1. The first radius is what? Is 6 squared. Then the second radius is what? Is 3 squared. Then the second radius is 3 over 2 all squared. Okay, there you go, guys. Remember, what are we getting? We're getting this from these radiuses that are sitting here. Okay, but remember, this does not give us the ratio, only gives us the pattern. So we've got T1, T2, and T3. So therefore, what is the ratio now? The ratio of this pattern is going to be given by T3 over T2 over T2. There, it's here. T3 over T2, which is T3 is that one, is 3 over 2 all squared all over 3 squared, should be equal to T2, which is this one here, over T1. T2 is 3 squared all over 6 squared. So if you were to put this in your calculator, you would realize that the ratio is going to be 9 over 36 is our ratio. Okay, so now what does the question say? The question says we need to find the sum of the areas. So now we can come and find the sum of the pattern of the radius. Okay, so now remember our formula here, we still have to put back this thing here into this equation here, but I will show you just now in case you're confused. Let's see. So we're gonna use which one? We're gonna use this formula here. We're gonna come here and say Sn is equals to Rn minus 1 all over R minus 1. So what do we have here? We have got A is what? A is this first term here, guys. Remember we said we are doing a pattern, so first term is 6 squared. So 6 squared is our first term. And then R is what? It's, we'll put a square bracket here. R is what? R it's 9 over 36 all to the power of 10 minus 1 close bracket all over 9 all over 36 minus 1. Okay, so we punch this together in our calculator. We punch everything. I can see that now I am found in 47.99. okay, so now this is our sum. However, we need to substitute back this sum into this equation here. Remember they said sum of the areas, sum of the areas. So now what can we do in this case? We can say, okay, now therefore sum of the areas is going to be equals to sum of the areas is going to be equals to pi, and then sum of that is pi what? 47.99. So that will be our answer, guys. All right, so we can therefore, but however we're not done, guys. Remember this is given in what? In terms of, it is given in terms of centimeters. Okay, so we can say here the answer will be pi 48 centimeter squared. If you don't put centimeter squared, you're gonna lose a mark or half a mark. Okay, so I hope you understood this, guys. Looks a little bit scary when you look at it from the beginning, but when you unpack it nicely and follow the basics, you should be okay. You should be okay. All right, so immediately when they say geometric sequence, put all the formulas that you're going to need there, so that when you continue, you know exactly what you are looking for. Let's move on now to 3.3. 3.3 said, which circle has a diameter of 3/128 centimeters? Okay, let's come this side. Okay, so we already know that the ratio, we calculated it that side, ratio it's 9/36. Okay, our first term is what? Is 6 squared. Right, so what are they asking us? They're asking us to find the circle that has got a diameter of, but remember, we're not working with diameter, so a diameter is equal to we're not looking for diameters. I mean to say, we're looking for radius. So radius is going to be equal to diameter divided by 2, which is going to be 3/128 divided by 2, which gives us an answer of, if we were to put this into our calculator, is going to give me 3/256. So that is our radius. So what do we do now? We know that a geometric pattern uses TNAR minus 1. So we already know this term here. They already given it to us. It is this one, 3/25. What are we looking for? We're looking for n, because we don't know what is n. Okay, so our first term here is what? Our first term here, it's 6. Okay, did I make a mistake? Our first term is not 6 squared, it is 6 squared. Okay, let me just check something here, guys, on my calculator. Our first term should be 6 squared. Okay, like we did it earlier, our first term is 6 squared. R is what? It's 9/36 to the power of n minus 1. No, sorry, to the power of n minus 1, but I'm writing 10 there, n minus 1. So therefore, once you have this, let's see now, you can say 6 squared, right? So now if you were to simplify this, 3n 256 is equals to 36, 9/36, and then there you go, then it's n minus 1. So therefore you can divide both sides by 36. Remember, guys, you can do that. You can't cancel out like this. No way, you can't do that. Because why? Because this is in bracket and is to the power of n minus 1. All right, great. So now when we come here, we can say, when we come here, we can say 3/256 all divided by 36, all divided by 36. Okay, or we can say that all divided by 36. This one and this one goes out, so we're gonna be left with 3/256 multiplied by 1/36 in this case. Yeah, so this side we're going to have 9/36 n minus 1. This is looking a bit messy. I'm not sure if I did the right thing. Okay, all right, it's fine, guys. Let's continue. Oh, okay, I see where I made my mistake, guys. See where I made my mistake. R is not R in this case is a half. Okay, let me remove all that. Let me remove all that. Remember now, in this case, we're not using the sum, we're just using the pattern as it is. Okay, so the pattern as it is in this case, it was what? So the pattern here, T1, T2, then T3. The pattern here as it is, it was 6, 3, 3 over 2. So our ratio in this case, T2 over that, which is equals to half. Remember guys, okay, that's where I made a mistake in this case. So our first term in this case will be 6. All right, so therefore now they're saying 3 over 256 is equals to the first term, which is 6, ratio which is half to the power of n minus 1. Therefore you divide everything by 6. Apologies about that guys, I could see that something doesn't add up. Okay, so therefore here when you divide, you are going to be left with a half over 2 n minus 1. It's equal to 1 over 512. Right, so with that, what you can do, you can put log on both sides, or you can make this to the power of 2. All right, you can make log both sides, or you can make this to the power of 2. Okay, you can go to your calculator and then do shift factors. There you go. Right, so what you can do, this one here you can write as 2 to the power of minus 1 in bracket n minus 1. Therefore this one here you can write it as 2 to the power of minus 9. Right, so here the bases are the same, therefore the exponents should also be equal. So minus n minus 1 is equals to minus 9. Divide both sides by minus 9 by minus 1 here. Divide by minus 1, divide by minus 1, you're gonna be left with n minus 1, it's equals to 9. Therefore you take 1 that side, n it's equals to 9 plus 1, which gives us n it's equals to 10. Right, and that's how you would deal with a question like this one guys. If you've got questions on 3.3, I initially made a mistake here, but at least we managed to correct it. So please guys, make sure that you follow the basics and you double check your answers in case you have made a mistake like me. I am Gaston Mapala, passionate about mathematics, right here at Maths with Gaston. Let me see you on the next upload, where we'll be doing question 4. Please give this video a like, share it with your friends, your family, your cousins, and also your classmates as well. If you haven't subscribed, please do subscribe, because this will help the channel to grow. See you in question 4.